Welcome to Lecture 32, 8.2, Distribution of the Sample Proportion. Alright, so Objective 1, describe the sampling distribution of a sample proportion. By definition, suppose that a random sample of size n is obtained from a population in which an individual either does or does not have a certain characteristic. The sample proportion which is denoted, and we say p hat. So let me highlight that. Denoted by p hat is given by the formula p hat equals x divided by n, where x is the number of individuals in the sample with the specified characteristic. The sample proportion p hat is a statistic that estimates the population proportion p. Now let's take a look at example 1. Suppose James surveyed 250 of the students at Windward Community College to see if they planned to take a class in the summer. Of those he surveyed, 75 of them stated that they were going to take a summer class. Find the sample proportion of the individuals surveyed who planned to take a summer class at WCC. Alright, so we're going to go ahead and use the formula p hat equals x divided by n. So the question here is, what is our p hat? Well, p hat, to find that, we need x and n, where x is the number of individuals with a specified characteristic. So we're looking for the number of students that were going to take a summer class, and we found out that 75 of them stated they were going to do that. And then n is the total sample size, so that was 250. Alright, so we can go ahead and plug that in. So p hat is going to equal 75 divided by 250. And what does that come out to be? Okay, so that comes out to 0.3, or 30%. So our answer would be, we could say 30% of students plan to take a summer class. Period. Now let's take a look at example 2. So based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion for samples of size A, n equals 10. This should be B, n equals 25, and C, n equals 60. The following images are based off of using StatCrunch's Bernoulli random data command, with a probability of 76% randomly generating from 2,000 samples. So we have two different ones. So for A, we use the sample of n equals 10. For B, we use the sample size, n equal to 25. And for C, we used n equals 60. So we used different sample sizes, and what did we notice about the graphs as the sample sizes slowly got bigger? So as we look at these graphs, if I tried to draw the normal curve on these, the one that ends up fitting the normal curve the best is actually the one with a higher sampling size. So we're going to go ahead and work with this idea that as the sample size gets larger and larger, it's easier to get something that is closer to the normal curve. Now the proof for this is not something we cover in this class. This would be something later on in a math journey if you want to go through that. But we're going to go ahead with that concept that the greater the sample size gets, the better our graph will start looking like the normal curve. So the sampling distribution of p hat. For a simple random sample of size n with a population proportion p, the shape of the sampling distribution of p hat is approximately normal. Provided that n times p, where n is our sample size, p is our proportion, and 1 minus p, or our probability for p, should be greater than or equal to 10. Okay, it needs to be greater than or equal to 10. So you always need to check that before you can assume that you have the normal curve, and go ahead and use all of the values and ideas we can use with normal curve. So you do need to check this before you can assume something works for the normal curve. Now, the mean of the sampling distribution of p hat is going to be mu of p hat equal to p, and the standard deviation of the sampling distribution of p hat is sigma p hat equal to the square root of p times 1 minus p divided by n. So notice here it's just talking about mu p hat and sigma p hat. So that's just denoting what the mean and the sigma are for when you use that little p hat. Let's look at example 3. Based on a study conducted by the Gallup organization, so this is very similar to what we just looked at, 76% of Americans believe that the state of moral values in the United States is getting worse. Suppose we obtain a simple random sample of n equals 60 Americans and determine which believe that the state of moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion of Americans with this belief. All right, well, what do we know? So if our sample size, or n, is less than 5% of the population, and we have n times p, 1 minus p, is at least 10, what can we do? Well, we know that mean of p is going to be p, and the standard deviation of p hat is going to equal the square root of p times 1 minus p divided by n, which is what we went over right up there. So let's go ahead and check that. Well, first off, the sample size of n equals 60. Is that less than 5% of the population? Well, the U.S. has a ton of people, and according to our book, it has over 300 million people. So that is definitely less than 5% of the population. So that is less than 5%. Okay, next we're going to check. So this is going to be first. Second, let's check n times p, 1 minus p. Is that going to be greater than or equal to 10? Well, n is 60, and our percentage is going to be 76%. We're given that in the problem. So 0.76 times 1 minus 0.76. Is that greater than or equal to 10? Okay, calculating that out, we get 10.944, which is indeed greater than or equal to 10. Just barely, but it is. So we can go ahead and assume that the distribution is approximately normal, which means, so we can assume the distribution is approximately normal. So then we have the mean of p hat is just going to equal the probability, which is going to be 0.76, and our standard deviation of p hat is going to equal the square root of p, which is 0.76, times 1 minus p, which is 0.76, divided by our sample size, which is 60. Plugging that into our calculator, we come out with approximately 0.06. And there we go. So all it does is to ask us to describe the sampling distribution, so we can just state these two values and we are good. Don't have to answer in a sentence. Objective 2, compute probabilities of a sample proportion. All right, so now that we know how to describe the sampling distribution of the sample proportion, we can now compute probabilities involving sample proportions. All right, so example 4. According to data from the Centers for Disease Control and Prevention, nearly 16% of adults in the U.S. report hearing trouble. In a random sample of 180 Americans, what is the probability that at most 12% have hearing trouble? So the first thing we need to do is, 1, check that it's less than 5% of the population size, and 2, n times p, 1 minus p, is greater than or equal to 10. Well, we do know that our sample size of 180 is indeed greater than 5%, because remember, the population for the U.S. is about 300 million. Let's go ahead and check that this value will end up being greater than 10, and if it is, we can assume it has a normal distribution. So n is 180, p is going to be 0.15, 1 minus 0.15 Is that greater than or equal to 10? Plugging that into our calculator, what do we get? We get 24.192, which I'll go ahead and round out to 24.19, which is indeed greater than or equal to 10. Awesome. So because we can assume that it is approximately normal, we can use our mu equal to the percent, which is going to be 0.16. And then our standard deviation is going to be the square root of our probability times 1 minus 0.16 divided by our sample size, which is 180. So we get that our standard deviation is going to be approximately 0.027. All right, so now we have found our mean and our standard deviation. And what we're really trying to find is the probability that our p hat is going to be less than or equal to 12, or 0.12. Okay, so what do we want to do for this? Well, if we can turn this into a z-score, then we can go ahead and look in our table and find the area to the left. Because remember, the table for z-scores will give us the area to the left, and we're trying to find the area to the left of 0.12. So let's go ahead and do that. So turn this into a z-score. Z-scores are going to equal our p hat minus mu p hat all over standard deviation p hat and mu p hat. So 0.12 minus our mu is 0.16 divided by 0.027, and we end up with a repeating decimal of negative 1.48. So this is approximate. So that is our z value. So we're going to go ahead and look in our table to find the area to the left. And we get the area of 0.0694. So probability of p hat less than or equal to 0.12 is going to equal that. And what is the interpretation? Well, if I rounded this out to about 0. So this is going to be scratch work. If I rounded 0.069, that would be about 0.07. So then also is 7 out of 100. So this is saying about 7 out of, running out of room here a little bit, 100 random samples of size. What size do we have? We had 180. So of a size 180 will result in at most 12% having hearing trouble if the population proportion is 16% of Americans with hearing trouble. Barely squished that in. There we go. All right, part B. Suppose that a random sample of 180 Americans who regularly listen to music using headphones results in 39 having hearing trouble. What might you conclude? Well, we can find the sample proportion here, right? Because p hat is going to equal x divided by n, and x is, in our case, 39, and the sample size is 180. So our p hat is about 0. Oh, that was an ugly, let me fix that, about 0.22 rounding. So what do you want to find? Well, we're going to compute p of p hat greater than or equal to 0.22. And if we find out that this is unusual, then any sample proportion, which is going to be greater than 0.22, is also going to be considered unusual. All right, so let's go ahead and turn this into a z-score like we did previously. P hat minus mu p hat divided by sigma p hat. We could find our mu and our sigma separately, but let's go ahead and just plug them into the problem right now. So p hat, though, we have is 0.22. Our mu, because we consider this to be normal, is going to be our proportion, which is, from the original problem, 16%, 0.16, divided by our standard deviation, which is going to be 0.16 times 1 minus 0.16 divided by our population size, which is 180. And that comes out to be, so z is going to equal 2.1957. Now, let's see. For our z-scores, though, the table doesn't actually go past 2 decimal places, so we're going to go ahead and round this up to, let's go with z equal to 2. Well, if we round it up for the hundredths place, that's going to bump us up into 2.2. But remember, ooh, that was ugly. Let me fix this. Okay, so we are looking for something greater than 0.22, but for our z-scores, that's going to give us the area to the left. So we're going to need to take 1 minus whatever we actually find for 2.2. So the value that we find for 2.2 is going to be 0.9861. 0.9861. So what does that come out to be? And we get 0.0139. Which, if I decided to do some scratch work to figure out what this means, that looks like about 1 out of 100 people would have this happen, which is definitely less than the 5% threshold we usually use for things being unusual. So we would conclude that this is indeed unusual. So this happens only 1 out of 100 times. So the results are unusual. So what is something we could conclude? Well, we can conclude that people who listen to music with headphones tend to have more hearing trouble. So we could say the population, let me change that, the population proportion of Americans with hearing trouble. Let me fix my with, I'll rewrite that with hearing trouble. Who regularly listen to music with headphones is higher than the general population. Alright, that is it for this section. Please email me if you have any questions.